giving me this opportunity. I'm from IIT-Tirupati, an emerging institute. And I have only 4-5 slides, so I'll complete it in 5 minutes. So I'm going to start where Dr. Deepak Dwivedi from RGIPT has ended. I congratulate him for developing the inhibitor. That's the storage part. Apart from that, when we come to ethanol from biomass, agri-waste, we have few more processes where we need to take care of the process material of construction, equipment material of construction. So I'll just briefly tell what are the process fluids that we come across. And they are like in delignification, we come across 16% NaOH, that alkali process. Satyan has mentioned about that. It's a very corrosive. And in saccharification, we come across formation of glucose from cellulose, starts from 0%, almost goes up to 16%. So we have to look at that and then evaluate whether SS304, the popular construction of material of construction, is suitable. And after that is fermentation, the glucose becomes ethanol. So it changes from almost 0 to 10%. In that due course, glucose keeps decreasing and ethanol keeps increasing. So it's a mixture of two solutes in water. So that also we have to look at. And last is distillation, again, high temperature ethanol, and that's a well-known thing in sugar industry. So we can take cues from there. And coming to the experiments I have used, it's a standard polarization test. Everyone says corrosion is unpreventable, but when it comes to actually getting the data for a graduate student, it is a difficult task because corrosion doesn't happen that fast to get the data. It's not a 9 to 5 experiment to get the data. If you want to get 1 millimeter per year, you have to wait for a year. So we have these accelerated tests, which are well established. I think I don't have to explain that. We use the popular Tafel slope to get the E-core and I-core. E-core determines how galvanic it is to the relative to other metal in the same electrolyte, and I-core determines how many millimeters per year it can deteriorate as a uniform corrosion. Of course, other things like pitting corrosion, we have to go for something else. Here I present some data. That's the glucose solution effect on the corrosion rate of SS304. We did experiments from 0 to 16. And it is found that it is reasonably stable. That means 0.01 mmPy is what 1 microampere per centimeter square is equivalent to. So, and also ethanol solution is also not that corrosive. That means the pipes made of 2 mm thickness or 2.5 mm thickness can last up to 20 years or so, in principle. But if pitting corrosion and things like that happen, probably we have to do the testing like the earlier speakers have mentioned, like the lifetime and things like that. Okay, now I come to the last slide of my talk. To conclude, SS304 is probably reasonable for 2G or even bioethanol applications. And future work is like there will be these slurries flowing. So in a flow situation, we have to determine the corrosion rates. And there can be microgalvanic corrosions, because if you go for flow reactor, one place it will be 0% glucose and other place it will be 16% or 8% glucose. So there will be this difference in the E-core at the two locations, and there will be galvanic corrosion resulting from that. And I'd like to acknowledge my earlier Ph.D. scholar, Mr. Sheikh Liaquat Ahmed, for developing the methodology, and my present B.Tech students, Mr. Brungeshwar and Likith Kumar. And I had a funding from NRB, Naval Research Board, to do one project. I just want to show that capability in this video. Like if you have a dual phase super duplex stainless steel having austenite and ferrite phases, it is possible we can actually simulate the 3D dissolution of the metal, like lattice model that Professor Robert has discussed in the post-lunch session. So that's where I would say. And we can work on incorporating I incorporated only the electrochemical part, solving the potential distribution and electric field and things like that. But stress on the metal side, CFD on the flow side can be incorporated. We can do FAC, flow accelerated corrosion, then stress SCC, stress corrosion cracking, and everything is possible. So probably those things can be taken up in the discussion. So I thank all the organizers for giving me this opportunity. Thank you, sir.
Anybody for a quick question to Sunil Kumar? I will talk to you during the tea time.
Sure, sir. Thank you, sir. I'm also alumni of IISc. I did ME at chemical engineering.
I have been coming to IIT-Tirupati often.
Oh, okay. Sure, sir. We'll meet, sir. Thank you, sir. Yeah. Yeah.
Thank you.
Thank you.
Thank you very much.
Shall I close this?
Yeah, that's okay.
This mouse is not moving.
It's okay. Don't worry.
Thank you.
So, this brings us to the final leg of today. It has been a very long day.